So today we are going to be looking at mathematics O level, ZIMSEC and Cambridge. So for the ZIMSEC we have our code 4001/1 for paper 1 and /2 for paper 2, and Cambridge IGCSE 0580 with its various papers for core and extended. The concepts are going to be the same. We are going to be looking at one topic. The tutor is say Jason is our tutor for mathematics. Now we are going to be doing a topic factorization today. Factorization, right? So in our lesson for today, the topic is factorization. So I encourage you to listen attentively, then pause, write notes where you should. In these questions, both ZIMSEC and Cambridge, we meet questions like factorize. We are going to answer them right away. Factorize ax plus bx. Ax plus bx, we look for the common letter on this ax and bx, and the common one is x. So we factor out x. After factoring out x, here we remain with a plus. Here we remain with b. We have, let me call this one a, this one b. Cx minus dx. Again, we look for the common letter here, it's x. We factor out x. After factoring out x, we remain with c here and with d. Then we have my plus y. My plus y. My plus y, on factorizing, we look for the common letter. The common letter is y. We factor out y. Factor out y. Then we remain with m only here plus. Now, what happens is when you are factoring out a number, the number divides where it is coming from. So my over y will remain with m. So here we have now 1. We have 1. So it becomes y m plus 1. Then we have part D. Part D, we have x c minus dx, c minus dc, c minus dc. That's what we said. The common letter is c. Common letter is c. C divides where it is coming from. We remain with 1. 1 minus d. We have factorized. What about if it involves a letter? It involves a letter. 3x plus 12. 3x plus 12. Now, 3 goes into 12. So, 3 is a factor of 12. So, we can factor out 3. We factor out 3. Factor out 3 there. We have x plus. Remember, we said the letter that is factored out divides where it is coming from. So this is 3x over 3, which is x. This is now 12 divided by 3, which is 4. And factorization is the reverse of expansion. So if we are to expand this one, we have 3 times x, 3x, 3 by 4, 12. So we come back to 12. What about 5y minus 30? 5y minus 30, we factor out 5. We factor out 5. We factor out 5 because 5 is a factor of 30. Y minus what? 30 divided by 5, that's 6. So it becomes y minus 6. That's first section of factorization. We go to number 2, factorize. Factorize, what are we factorizing? X squared y plus xy squared. X squared y plus xy squared. Now we look at the letters. We have x squared here and x there. Now we need a number that goes, a letter that goes into x squared and x. It is the smaller one. The smaller one is the one that is common in the two. So we factor for x squared and x, we factor out the smaller is x. And for y and y squared, which one is smaller y, we factor out y. Having done so, we now have x squared y plus xy squared, right? We had x squared here, we removed one x, so even if we say x squared over x, one x will remain, so we have x, y has been factored out, plus the x has gone out, we have y squared, we factor out 1, we remain with 1y. Then we have also x squared, x cubed, y squared plus x, y cubed. X cubed and x, the smaller one is x. So let's factor out the x, right? Then what about y squared and y cubed? The smaller power is y squared. So factor out y squared. When we do that, we now have, remember we factored x only from x squared. So it's like x cubed divided by x to the power 1. We subtract powers. So in other words, we remain with x squared here plus y squared has been factored out. So we remain with the x squared only, plus x has gone out. We had y cubed, and from y cubed we factored out y squared. So it means we are left with 1y. Y cubed, we factored out y squared, we are left with 1y. Because y cubed, if divided by y squared, it's like y times y times y over y times y. Y cancels, we remain with 1y, which is the one we have. Or y cubed over y squared. When you are dividing them, you subtract the powers. So we remain with a single y. So y cubed over y squared, we remain with y alone. Case number 2 of factorization. Now, I have this question from 2025 June, IG, Cambridge, 2025 June. 4a squared plus 16a factorized. This is 3-3, June 2025. We have 4 and 16. 4 and 16. 4, a factor, the highest factor of 4 and 16 is 4. So 4. 2 is a factor, but you need the highest one. 4 and 16, we factor out 4. Then a squared and a, we factor out the smaller power, which is a. 4 has been factored out. From a squared, we took a, so we remain with a plus. Right? The factored out number divides where it is coming from. So we will have here 16 divided by 4, which is 4. 4. We then have 4 is a has been factored out. So it's a plus 4. That's case number 2 of factorization. Now, before we look at the other factorization, which we are going to look at in number 3, which says factorize. Now, let's say we have x squared minus y squared. X squared minus y squared, we look for common letter to here and on this one. X is here, but we don't have x there. Y, we have y here, but we don't have y there. So it means, unlike the previous examples, where there was a common letter that could be factored out. In our case, we do not have a letter which can be factored out. So in this is a special case. This is a special case where we use a method called difference of two squares. Difference of two squares. Now, difference of two squares is a method for special cases like this one. But look at the words, difference. It means this method applies only when there is a subtraction which is different. Because by difference, it means we are subtracting of two numbers. We must have two numbers, 1, 2. In our case, we have x squared and y squared, 1, 2. X squared and y squared. And what are those numbers? They are squared. They are numbers obtained after squaring a certain number. In other words, these are numbers which have a whole number square root. So squares have a whole number square root. Now, for such a case, factorization becomes easy. You put your two brackets. We have in the first bracket, first number subtract second, then the other bracket, first number plus second. So it becomes x minus y bracket x plus y. You have factorized. What about if I had n squared minus m squared? This is n minus m bracket n plus m. Now, when you are using difference of two squares on product, when you start with n minus m bracket n plus m, it is the same as n plus m, then subtraction on the other side. No problem. No problem. You can even start with the plus, then the minus. But for consistency sake, we start with the minus, then plus. Then we have example C, x squared minus 25, x squared minus 25. Difference of two squares is suggested here, but we have to first write 25 as a square. Which number do we square to get 25? What is the square root of 25? 5. So this is x squared minus 5 squared. Then when we do that, we have first bracket x minus 5, other bracket x plus 5. X squared minus 36, what do we have? X squared minus 6 squared. X squared minus 6 squared, then we have what? X minus 6 bracket x plus 6. X squared minus 100, x squared minus 100. Right, x squared minus 100, we need to find the square root of 100. The square root of 100 is 10. 10 by 10 is 100. So this becomes x squared minus 10 squared. Then we have x minus 10, x plus 10. What would be the factorization of y squared minus 1? Y squared minus 1. Which number do we square to get 1? It's 1. So we have y squared minus 1 squared, which is y minus 1 bracket y plus 1. Factorization. Before I give more examples, let's have a recap. We found that the factorization, in many cases, you factor out a letter or a number, or letter and number, then you put your brackets. Now, on difference of two squares method, we should have a subtraction sign and the numbers written as a square. Now, let's look at more examples on difference of two squares. Difference of two squares. But before that, we need to know that 4 times 4 is the same as 4 squared, that's 16. 6 times 6 is the same as 6 squared, that's 36. 9 times 9 is the same as 9 squared, that's 100. And 10 times 10 is 10 squared. 9 times 9, that's 81. 10 squared, which is equal to 100. So, when we have 100, we know it's 10 squared when we have 81. We know it's 9 squared when we have 36. We know it's 6 squared when we have 16. We know it's 4 squared when we have 9. That's 3 squared when we have 4. That's 2 squared. When we have 49, that's 7 squared. 64, that's 8 squared. 144 is 12 squared, and so on. So now we look at this G. We look at example G. Factorize 16 minus y squared. 16 minus y squared. We know that 16 is 4 squared. So we start with 4 squared, subtract y squared. Then we have 4 minus y bracket 4 plus y. 4 minus y bracket 4 plus y. Then we have h. X squared minus 1 over 25. X squared minus 1 over 25. This becomes x squared minus 1 squared over 5 squared. We know that 25 is 5 squared. So we have x squared minus 1 over 25 becomes x squared minus 1 squared over 5 squared. Then we have here x minus 1 over 5, x plus 1 over 5. We take what is under the squared. Under the squared, 4 minus y, 4 plus y. Under the squared, we have x 1, 5. So x minus 1 over 5 bracket, x plus 1 over 5. What do we have on h? On I is y squared minus 1 over 36. Even if it's y squared minus 1 over 36, 1 over 36, let's say 4 over 25. This becomes y squared minus 2 squared over 5 squared, 5 squared. This becomes y minus 2 over 5 bracket y plus 2 over 5. Y minus 2 over 5 bracket y plus 2 over 5. Then we have here another example. Let's call it number 3. Number 3, we have factorize a 5x squared minus 20. 5x squared minus 20 becomes 20 cannot be written as a squared. 20 is not a squared because here we don't have a number that multiplies itself to get 20. 4 by 4, that's 16. 5 by 5, already at 25. But we can factor out 5. 5 goes is a factor of 25 there. We have x squared minus 4. After we get that, we now say 5. We then have x squared minus 2 squared. Because 2 squared, 2 by 2 is 4. X squared minus 2 squared, then we have 5. X minus 2, x plus 2. And normally these questions say factorize completely. How do you factorize completely? 3x squared minus 48. Factor out 3, we have x squared minus 16. 48 divided by 3, 16. So we have x squared minus 16. What else do you do? We know that 16 can be written as 4 squared. For us to have difference of 2 squares, that's 4 squared. Then difference of 2 squares has been set, x minus 4, x plus 4. But we need not to fall under the temptation of writing 4 as 2 squared. We already have a squared and a squared We have arrived. There's no need to say 4 is also 2 squared. It means that will be 2 to the power 4, right? When we have squared, we are done. So we have 3x squared minus 16, 3. We have that. What else do we have? What else do we have? C. 3c. 27 minus 3y squared. Do we have square root of 27 as a whole number? We don't. But 3 is a factor of 27. Factor out 3. Now this becomes 27 divided by 3, that's 9 minus, right, y squared. We remain with y squared. That's 3. 9 minus y squared, which becomes 3. 9 is 3 squared minus y squared, which becomes 3. 3 minus y, 3 plus y. So 3 squared, 3 minus y, 3 plus y. We have factorized. What about 9 minus 25x squared? We don't have a factor of 9 and 25, but you look closely. 9 is 3 squared. Look closely. 25 is 5 squared, x squared. When we do that, we have 3 minus 5x. Take what is below the squared. 3 plus 5x. We have 4x squared minus 25. 4x squared minus 25. This is 2 squared x squared minus 5 squared. Now we have 4 squared. Difference of 1, 2 squares. We have brackets. The first one is 2x minus 5. The other one is 2x plus 5. We have factorized that one. Then what about we have a case where we have EF. Let's look at F, a special case. F, we have 9x squared minus 36. 9x squared minus 36 has two ways of working. The first one is realizing that 9 is a factor of 36. So we factor out 9. After factoring out 9, we now have x squared minus 4. X squared minus 4. So then we have 9. And then x squared minus 4, that's 2 squared. Then we have 9. And x minus 2, x plus 2. Then some, however, do it this way. They will say 9 is 3 squared. 9 is 3 squared, x squared. Then they will have 6 squared here. But this method will be a problem. Then they will have 3x minus 6 bracket, 3x plus 6. This has not been factorized completely because 3 is a factor of 6. So factor out 3. We have x minus 2. Then factor out 3 there. We have x plus 2. Right? 3 times 3, that's 9. Then we have 9, x minus 2, x plus 2. Long method. The first one is realizing that 9 is a factor of 36. Factor out 9. You get it perfectly smart. Then what about x cubed minus x? X cubed minus x means I must factor out x. We get x squared minus 1. You have factorized, but you have not factorized completely. Completely means I can proceed x squared minus 1 squared. That's x minus 1 bracket x plus 1. Having done this, we have looked at factorization, but I'll give 2 or 3 more examples. 2 or 3 more examples before we give practice questions. Let me call that number 4. Factorize completely. Factorize completely. What are we factorizing? 8x squared minus 18. 8x squared minus 18. 8 is not a factor of 18. Which number then goes into 8 and 18? The biggest. 2 can go into 8 and 18. 4 goes into 8 but not into 18. So 2 is the highest. I factor out 2. Then I have 4x squared minus 18 divided by 2. That's 9. So I have 4x squared minus 9. Then we have 2. We can factorize it further. 4, that's 2 squared x squared minus 9, that's 3 squared. We factorize this, we get 2. 2x minus 3 bracket 2x plus 3. Then 5h squared minus 45k squared. We have factorization of this one. We have removed 5. We remove 5. We have 5. Then we have h squared minus 9. 9k squared. H squared minus 9k squared. We have 5. H squared minus 3 squared k squared. And we have 5. H minus 3k bracket H plus 3k. Right, so these are our practice questions. For our practice questions, you can go through, you work it, and then that's my contact number, plus 263773759448. So you can go through and work the questions. You can also practice more from past exam papers. For ZIMSEC, you can use Green Books Cambridge, download question papers from the internet, and you'll be good to go. If you go through our notes, go through the examples, you'll be able to solve almost all of these questions. Thank you very much. We meet in the next lesson where we'll be doing a coverage of our syllabus. So I'm going to do almost every topic. Until we meet again, thank you.